This video is going to take a look at binary numbers, how to convert them into different types such as denary, and how to add them and do binary shifts. The strangest thing about computer science is trying to get your head around how every single thing a computer does is in binary. Everything it sees is in ones and zeros. So computers use logic circuits using a 1 and 0 as the only two options to show whether it's high or low voltage. So in other words, whether electricity is flowing or electricity is not flowing. That's why you see power buttons on devices with a 1/0 on it, as in on or off. Binary comes from the word bi, so two or twice in Latin. If you think about things that start with bi, you've got bi-weekly, bicycle or bicycle, bifocals. Those things have got two lenses, two wheels, twice a week. We've already covered this in the units video, but it's useful to just keep going back over it again. So with bits and bytes, if a 1 or a 0 is 1 bit, that's the smallest measure of data a computer can have. Then the next one is a nibble, which is 4 bits together. Now the highest number that you can create from a nibble is 15. That is all of the different numbers added together. And you can have 16 combinations because you can have 0 as well. Then you go to 8 bits, and this is the most common kind of unit that computers save data in. So you often see things in bytes or kilobytes or megabytes rather than bits. As you can see going down through the table, it starts to progress and go to basically 1,000 times, 1,000 times, 1,000 times, 1,000 times. You need to know those in order, what is bigger than the other. I think you should be able to count in binary at least up to 15, because it really helps when we're looking at the binary conversions and when you're doing things like addition. Also helps when you're doing hex, because you learn how to do a nibble and calculate what hex value it's going to be. So basically it goes with 0, then 1, then 1 0 1 1 1 0 0 1 0 1, and so on. Now the best way of doing that is to use what I call a conversion table, and I'll show you what that looks like. So you need to be able to draw a conversion table. The easiest way of doing it is to start at 1, go to the left and double it, double it, double it, double it, and keep doubling it until you've got 8 boxes. This is now 1 byte. So this is 8 bits, which creates 1 byte, and that is what you're going to need for GCSE. That is what you're going to need to do your conversions and your additions. This is because it's base 2, it's binary, which means it's base 2 numbers, which is why it doubles. It basically times 2 times 2 times 2 times 2 and goes along. Now we use this conversion table because when you get given a number in binary, you can put it straight into that conversion table and easily put it into denary. We can also use the conversion table to convert denary into binary as well. So I'm going to show you both methods now. So with a conversion table, if we put in all of those binary numbers, so 0 1 0 1 0 1 1 0, that binary number has been put into my conversion table. All you have to do to convert that to denary is add up every time there is a 1. So every time we find the 1, we add it. So there's a 1 under 64, there's a 1 under 16. So 64 and 16 is 80. Then we add a 4 is 84, and we add a 2 is 86. So that binary number is 86. That's really easy, isn't it? So if you have to do it the other way and you want to convert from denary into binary, then what we have to do is every time you want to find what it is in binary, you need to start with the biggest number that fits into your number. So if we use the number 86 from before, the biggest number that goes into 86 is 64. So you put a 1 in, and you need to subtract 64 from your number and carry on. So 86 minus 64 is 86 minus 64 is 22. So the biggest number that goes into 22 is 16. So you put a 1 in 16, and you take 16 off 22, and you get 6. Biggest number that goes into 6 is 4, so you put a 1 in. Take the 4 after 6, and you get 2. Put a 1 into the 2, and then you've got 0. Then all you do is put zeros in all the boxes that are empty. So let's do another full example. If we want to convert 93 into binary, what we have to do is put the biggest number that goes into 93, which is 64. So we put a 1 in there, subtract 64 from 93, and we get 29. So then we go to the biggest number that goes into 29, which is 16. You put a 1 in, take off the 16, and you get 13. Biggest number that goes into 13 is 8. Put a 1 in the 8, and then subtract it off. Get left with 5. Biggest number that goes into 5 is 1. Put a 1 under the 1, and you've got 0, and then 0 in all the other boxes. Now that you've mastered that, sometimes we have to add two binary numbers together. So the obvious easy way of doing this would be, right, well, what's 45 plus 60? It's 105. So I'll just put 105 straight into the box. But in the exam, you are expected to do this properly so that you have the carry bits. Now to get the carry bits, you've got to add the binary properly, and that's what we're going to do here. This is the bit where counting in binary is really important. You need to know how to do it. So if you look at the top two rows, 45 and 60, that is 45 and 60 in binary. Now what you've got to do is add those two things together. So as you go down, you basically got to add up 1 and 0. Now what is 1 plus 0? We know that 1 plus nothing is 1. So underneath, we just stick a 1. On the next line, which is underneath the 2 column, 0 plus 0, we know that nothing add nothing is nothing. So we put 0. Now this is where it gets tricky. So on the next one, 1 plus 1, we know that 1 add 1 is 2. But 2 in binary is 1, 0. So you've got to put in a 0 in that column, and the 1 goes in the carry bits row. So that's why you can see a 1 in the carry bits row. Then what you've got to do is add up all the 1s in the columns. So 1 plus 1 plus 1 from the carry bit is 3. So 3 in binary is 1, 1. So you put 1 in and then carry the 1 across. Then every 1 in this column is 1 plus 1 is 2. So you put a 0 in and carry the 1. Then the next one, it's going to be 1 plus 1 plus 1 again, which is 3. So it's 1 and carry the 1. And then the last one, it's just 1 from the carry bit, so you put a 1 in. Everything else, so on the next one, for example, is just 0 plus 0. You just put 0 in and that's it. So you would get 1 mark for the whole row that makes 105 and 1 mark for the carry bits at the bottom. If you ever get an answer where the carry bits float over, so if I had a 1 in the carry bits section of 1 to 8, that would mean that I was going to have an extra 1 on the other side. So if I put like in the under 1 to 8, if you ever get 1 plus 1 to make 2, you're going to have to move a carry bit across. Now that means it's not going to fit in one byte anymore. This is called an overflow error. So a binary shift is really quite an easy kind of concept. All you've got to do is you'll be given an original number that you can stick into your conversion table. And then all you've got to do is move the binary however many places the exam question says. So in this particular example, it's just moving it one step to the left. So it would be a one shift left step. So the original number, what you do is you take the furthest left number, which is in 128, and move it across one. So in other words, the second number across, which is under 64, that 1 goes now under 128. The 0 under 32 now goes under the 64. The 1 and the 16 now goes under the 32, and so on until you move it all across. So what you see here is that the 0 is now off the list, it's gone. And we add a 0 on the end just to pad it out. Now what a binary left shift does is it doubles the number every time you shift it to the left. So a one shift left is like doubling it, it's like timesing it by 2. If I move it to the left again, the number will double again. So from its original form, it's like timesing it by 4. If you do it 3 shifts, then it would be timesing it by 8, and 4 shifts timesing it by 16. A right shift binary shift is basically the same thing, but moving it the other direction. Now what the binary right shift does is it's division for binary. So one shift to the right is dividing it by 2, 2 shifts is divided by 4, 3 shifts divided by 8, and so on. So we can see that the number 90 in binary, if we shift it one space to the right, it suddenly turns into 45. All you've got to do is move all the numbers across. Anything that falls outside of the normal 8 is lost, and you add a 0 in to pad it out. That's the end of this video on binary numbers. I will produce a video where I do some worked examples of exam questions just to make it a little bit easier.